In section 6.4, you're going to use the factor theorem to determine factors of a polynomial and factor the sum and difference of two cubes. In section 6.3, you divided polynomials and found their remainders. And one of the things you're going to do in section 6.4 is determine if a binomial is a factor of a given polynomial. So remember, if a number is divided by any of its factors, the remainder is always going to be 0. So if we think of the number 12 and we divide it by 2, divided by 3, divided by 4, divided by 6, divided by 12, we're going to get a remainder of 0. Those are all factors of 12. The same is true if a polynomial is divided by any of its factors. The remainder is going to be 0. Now, in section 1.7, you use direct substitution to evaluate a function, and I just want to remind you what direct substitution is. It would be if you're given this function and you were asked to find f of 2, that would mean that you would just substitute the value 2 here and here, so f of 2 would be 2 plus 1 or 3. In this section, you're going to use synthetic substitution to determine if a binomial is a factor of a polynomial. So what you need to do when you're using synthetic substitution is you basically do synthetic division. And the factor theorem will tell you that any polynomial you have, p of x, we'll just call it, if x minus a is a factor of the polynomial, if and only if p of a equals 0. So when you substitute this into the polynomial, if it equals 0, then you know you have a factor. Okay, you're going to now use synthetic substitution to determine if a linear binomial is a factor. All right, so here is our linear binomial, and we want to check to see if when we would divide this by this, if we end up with 0. Instead of doing long division, what we can do is we can use synthetic division and look to see if the remainder is 0. So we set that up by setting x plus 1 equal to 0. That's the number that goes in when we solve, that goes in the backwards L. And x is negative 1, so we're going to put that here. And then we're going to put the coefficients, 1, negative 3, and 1 in the first line. And then the first step we do is we drop that 1 down. And from there we just multiply the 1 times negative 1. And that's going to give us a negative 1, which goes right underneath that negative 3. And then we add down the column to get negative 4. Then we're going to multiply negative 4 times negative 1. That's going to give us a positive 4. That goes underneath the 1. And when we add, we see that we have a remainder of 5. So when you're asked if a binomial is a factor of a polynomial and you have a remainder that's not 0, the answer is no. So x plus 1 is not a factor of this polynomial. Okay, there's one for you to try. So you can turn off the video or pause it and then turn it back on or play when you're finished with that one. Now in section 5.3 you factored polynomials of degree 2. So those were quadratics. In section 6.4 you're going to factor polynomials of degree 2 and higher. So always remember that when you're factoring, first step is to take out the GCF. That's your greatest common factor. And you can still factor, but it just makes the factoring easier because your numbers are smaller. Now, in order to factor, you're going to look at the number of terms and then decide on a factoring method to use. So let's start out with factoring 4 terms. After you take out the GCF, if you have 4 terms, I'm not sure if you can see that very well, that says try grouping. So if we look at this polynomial, we have 4 terms. So we want to try grouping. We're going to look at them 2 at a time and see what the GCF is. So looking at just these 2, let me cover up the other 2. They both have an x squared in common. So we can pull out an x squared, and when I do that, I'm left with x minus 1. Now when we look at the next 2 terms, we're going to see that we can pull out a 25. And instead of saying 25, we always want to take the name with, the sign with the number. So we're going to divide it by a negative 25. When I do that, that's going to give me a positive x and then minus 1. So now I have minus 25x minus 25 times x minus 1. Now I have an x minus 1 that's common in both of those, so I'll take that out and write it out front. And then I'm left with an x squared minus 25. Now, when you're factoring, you want to factor or use techniques until you get x to the first power. So there's a couple of different ways that you can factor this. One way is to say, okay, well, there is no b term there, so I can say x squared plus 0x minus 25, and then I can do the factors of 25 that sum to 0. So that would be positive 5 and negative 5. Another way that you can do it is a shortcut, and I'm going to write this down at the bottom here. Underneath factoring 2, we'll just add down here factoring the difference of two squares, and I've underlined difference because it has to be subtracting, and the squares have to be like 1 squared would be 1, 2 squared would be 4, and so on. So they have to be a perfect square. And if that's the case, if you have two terms, they're both perfect squares, and there's a subtraction sign in between. So it has to be a difference, and it has to be squares. Then there's a shortcut to this. You can just take the square root of this and the square root of that, and that would give you x and 5. And then you would just alternate the terms. One would be positive, one would be negative. So if I were to multiply, this would be x squared minus 25 factored would be this. So I just want to show you that it works. If I multiply that out or FOIL it, I'm going to get x squared plus 5x minus 5x minus 25. So when the signs alternate, the middle two terms simplify to 0. So this is going to simplify. I'm just going to write it down here, x minus 1, and then this factors into x minus 5, x plus 5, and then you're finished. These are both degree 1. If you have 3 terms, the factoring, after you take out the GCF, if you have a quadratic, which means your degree is 2, you want to use the technique you used in section 5.3. And that technique, hopefully you remember that, you take out the GCF first. So here I'm going to divide everything by 2. And then I want factors of a times c, so now I'm left with 2x squared plus 7x plus 3. I want factors of a times c, which would be 6 because it's 2 times 3, and they need to sum to b, and b is the 7. So I can list the factors 1 and 6. I have 2 and 3, and when I multiply 2 times 3 I get 6. But when I add them I get 5. So what I want to use is 1 times 6. That's going to give me 6. 1 plus 6 is 7. We do that to rewrite that middle term, to change it from 3 terms to 4 terms, because when it's 4 terms then I can use grouping. So I'll rewrite this. This stays the same, 2x squared. The 7x changes to x plus 6, or sorry, x plus 6x, and then plus 3. Now I'm going to use grouping. I look only at the first 2 terms and I see that they both have an x. So I'm going to pull an x out. I divide this by x and I'm left with 2x. I divide this by x and I'm left with 1. So once you factor, you should be able to distribute again. That gives you 2x squared plus x. All right, now I'm going to look at the next 2 terms, which would be 6x plus 3. I can pull out a 3 out of both of those and I'm left with 3 times 2x plus 1. And factoring again, I have, looking for what's common with both of them, I have a 2x plus 1 and a 2x plus 1, so I'm going, let me write this out here, I'm going to write the 2x plus 1, and then what I'm left with is x plus 3. All right, the last thing that we need to go over for factoring is factoring 2 cubes. So you need to look at the degree and the number of terms to decide on what factoring technique to use. So here, factoring 2 cubes, it means the first one has to be a cubed, and you might not be able to see that very well. Those are both cubes. And basically you just remember a pattern for this one. Let's just list some of the cubes off to the side. 1 cubed equals 1, 2 cubed is 8 because it's 2 times 2 times 2. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. So if you can recognize the cubes when you're looking at binomials, it makes your factoring a little easier. So what has to happen to use this technique is you have to have 2 cubes. All right, take out the GCF always. So let's just start with this one right over here. If you're looking at these, there is a pattern. Oops, there goes my light again. If this first sign is positive, then the sign pattern is plus, minus, plus. And you just have to remember that. If the sign is negative or subtraction, then it's going to be minus, plus, plus. You factor them exactly the same way. The only difference is if this is a plus, you use this sign pattern. If this is minus, you use this sign pattern. So what you're going to do is you're going to take the cubed root. Well, first let's pull out a GCF here. Let's find our example. We're going to pull out a GCF. We can divide everything by 2, and the highest power we can divide is x squared. So we're going to divide that by, the GCF is 2x squared, and that's going to leave me with x cubed minus 8. Well, this is a cube, and 8 is also a cube. So what we're going to do, we need to, going from here to here, they took the cubed root of each one of these. So you have to remember that I still have this factor out here. So I'm going to kind of put a box around that so I don't forget that. If I take the cubed root of x cubed, that gives me just x. So I'm going to represent a by x. And if I take the cubed root of, and I'm going to ignore this sign for now, the cubed root of 8 is going to be 2. So we're going to say b equals 2 because this is the pattern that they're using a and b for the pattern here. So what this says is now that I've identified a and b, this is a subtraction, so I'm going to use this one right here. When I factor it, all I have to do is write a and b in the first set of parentheses. So I'm going to write x to the first power, 2 to the first power. So the first set of parentheses, they go to the first set, to the first power. Second set of parentheses, they go to the second power. So I'm going to put x squared here, and then this is going to be 2 squared, or I can just write that as 4. Okay, so the first set of parentheses, they're raised to the first power. Second set of parentheses, they're raised to the second power. And then in the middle, you just multiply a times b. So our a is x, our b is 2. So we're just going to say 2x. Now, since this is a subtraction problem, I put subtraction here, and then I put plus plus here. So minus plus plus. And I will give you several of these problems for you to practice with. So my final factored form is going to be 2x squared times x minus 2 times x squared plus 2x plus 4.